What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 2.4, solving equations with variables on both sides. So we're still going to see a lot of the same rules with undoing, adding, and subtracting, undoing, multiplying, and dividing, except now we just have to move all of our variables to one side instead of having variables on the left and right side. So this is what it's going to look like. Anytime we have variables on both sides, we want to make sure, do we need to distribute first, combine like terms, then we're going to move variables to the same side. Typically, I'm going to try to get you to start just defaulting by putting the variables on the left-hand side. And then once you get more comfortable, you can always move your variables to the left or the right side. But this is just a good starting point, just so you don't get everything mixed up. We're going to undo any addition or subtraction, then undo multiplying and dividing, and then check your answer. So the only new step we're adding in here is step 3, moving those variables to the same side. If you haven't yet, take time now to pause this video, copy this in your notes, and when you're ready to move on and try an example, click play. All right, here's our first example. 15 minus 2x is equal to negative 7x. Again, what I told you to do is put the variables on the left-hand side. However, this one is actually easiest if you move the variables to the right-hand side. So I'm going to show you what that looks like first. That means I want all my variables over here. So one thing you could do is just label what side you want your variables to be on. That way you know you're only moving those things over there. How I'm going to do that is I see this minus 2x, and notice there's a minus in front of it. So to move it, I'm going to do the opposite of minus 2x, which is plus 2x. What I do to one side of the equation, I will also do to the other to keep it balanced. Remember, that's just the algebraic reasoning rule of the addition equality property. When I do that on the left side, I'm still going to have 15 here because that negative 2x and positive 2x cancels out, and then equals to negative 7x plus 2x is negative 5x. Now I'm ready to move on to any adding or subtracting or multiplying and dividing. Here, in order to solve for x, all I have to do is divide by negative 5 because what's going on right now is it's being multiplied. So I'm just doing the opposite of what I see. Negative 5 divided by negative 5 just gives me my x, and 15 divided by negative 5 gives me negative 3. If I wanted to check this, all I have to do is plug in that negative 3 in where the x is. So that's what I'm doing right now, and then we'll kind of talk about it. Okay, so first I would do 2 times negative 3, that's negative 6, and then 15 minus negative 6 is a positive 21. And then over here, negative 7 times negative 3 is also a positive 21, so I know I got it right. Let's see if you can try this one on your own. Maybe pause the question here, pause the video here, see what you can do for number 2, and then when you're ready, click play. All right, once again, decide what side you want your variables to be on. I'm going to put mine on the left-hand side because I'm feeling like it's a little bit easier to do here. So I'm going to add 3x to bring it over here with the negative 2x. Okay, when that happens, negative 2x plus 3x is a positive 1x. You can write just x or 1x. I'm going to write 1x for now, just so you can see it visually, but keep in mind that can also be represented just by an x. Plus 10, and then is equal to 12. Okay, now I'm ready to undo any addition or subtraction. I see plus 10, so I'm going to subtract 10 from both sides. So now I have 1x is equal to 12 minus 10 is 2. And then the last step is to undo any multiplying or dividing. So I'm going to divide by 1, where I get x is equal to 2. Okay. Again, I can check this by plugging in wherever 2 is. 2 times 2 is 4. Sorry, that's negative 4. Negative 4 plus 10 is equal to 6. And then 12 minus 3 times 2, that's 12 minus 6. That's also equal to 6. So I know I got it right. Again, let's go ahead and copy and solve the following equation. Pause the video here, and when you're ready to check it, click play. First thing I'm going to decide is where do I want the variable? I want the variable on the left-hand side here just because there's already one variable alone. So I'm going to do that by subtracting 2x from both sides because right now this 2x is a positive 2x. So I'm going to do the opposite. Being very careful here, negative 3x minus 2x is a negative 5x. The 2x and the negative 2x cancels out, and all that's left is 19. Now I'm ready to divide. I don't have anything else to add or subtract, so I'm dividing by negative 5 on both sides. This is where we're going to get a decimal or a mixed number. Because this is an improper mixed number or improper fraction, you can keep it like this, negative 19 over 5. Or if you change it into a mixed number, 5 can go into 19 3 times with 4 left over. Or some of you prefer decimals, you got negative 3.8. Any one of those 3 options would work for number 3. We've got number 4, and then we've just got a word problem here for number 5 before we're done. Number 4, again, pausing the video, try this one on your own. When you're ready to check it, click play. All right, for number 4, I decided variables would be on the left-hand side, so I'm going to subtract 4 from both sides first. So subtracting 4n from 2n, that's a negative 2n, minus 6 is equal to 1. Once you get to this point, this is just a 2-step solving equations. Adding 6 to both sides, I'm going to get negative 2n is equal to 7. Dividing both sides by negative 2 is my final step. N is equal to negative 7 over 2, or negative 3 1/2, or negative 3.5. Okay? For last one, number 5, copying and solving the following equation. This one is going to be a word problem, so we just want to make sure we're understanding the language with it. Go ahead and pause the video, read through it, see if you can set up your equation first, and then click play to see if you've set up the equation correctly. Then we'll solve it together. All right, provider A charges $75 for installation and $39.95 per month. So right away, I know that $39.95 per month has to have the variable X plus a $75 fee. Provider B is also charging some money here. They're not charging installation fee, but they are charging $54.95 per month. So their equation would just be 54.95. The reason why I set this up like this, 39.95x plus 75 is equal to 54.95 because I want them to be the same amount after how many months. So now we're solving for x, which is the number of months. What I want to do first is get variables all to the same side. So because I have a lone variable on the right side, I'm going to go ahead and move all my variables to the right side. So I'm going to subtract 39.95x from both sides. When we do that, 54.95 minus 39.95 is 15x, and that's equal to 75. Final step, dividing both sides by 15. 75 divided by 15 is equal to 5, so after 5 months, they'll be the same amount. That's going to conclude our lesson for today. Thanks for tuning in, and we'll catch you next time.